Okay. So this is the problem I was solving. We did not solve it. Anybody tried to solve this problem? Any one of you? Did you try or not? Yes or no? Please answer. Prashant, can you hear me? Am I audible?
Yes, sir.
Yeah. Did you solve this problem? Anybody tried this or not? Did you try?
I couldn't.
You could not. Okay, fine. Anyway, one more information. I have uploaded the notes in your Teams. Yes, I can just download and read. Huh? Both modules 1 and 2 I uploaded. So let's see. Okay, I think I have explained everything in the last class only. So we said that there is a process. There are three processes: 1 to 2, 2 to 3, and 3 to 1. Okay, these three processes together form a cycle. Now, now we have to find out the work done during this cycle. So if it is cycle, work done in a cycle is area enclosed by the cycle. See, there is area. No? This we call it as cycle. Because it closes, the process starts here and comes back to original state. Therefore, it is called a cycle. So it goes through a series of changes, returns to the same state. It encloses an area. This area is called a network. Okay? If the process is counterclockwise, if process is 1 to 2, 2 to 3, 3 to 1, then a network will be positive. If the process is opposite, let us say process is 1 to 3, 3 to 2, 2 to 1. In that case, the network will be negative. Okay, counterclockwise. Sorry. Yeah. This is clockwise, no? Yeah. Clockwise is positive. Counterclockwise will be negative. Okay. Is that clear? Work done in a clockwise is the positive. Counterclockwise will be negative, like that. So this I need to find out work done. So how to do that? Simple it is. I need to find out the work done in each process. That's all. Okay. To get this, what we have to do? For all the process individually, I have to calculate the work done. So process 1 to 2, integration PdV. Process 2 to 3, integration PdV. Then process 3 to 1, integration PdV. That's how we have to solve the problem. So here the mass of the air is given 10 kg. Pressure, initial pressure is 20. 20 into 10 to the power of 5 pascals or the bar, we call it as, okay, 20 bar pressure. Then V1 is a volume, right? Then volume at state 2 is given as, volume at state 2 is not given. Instead here it says volume, where is that? The fluid reversibly behind piston law until volume is doubled. That means V2 is twice V1. V2 by V1 is equal to 2. So therefore V2 will be equal to 2 into V1. That is 0.1 meter cube. Okay. So this is all given. Please write down this. Are you writing?
Yes, sir.
Okay. So then now comes it is given here. Process 1 to 2 is the equation for process 1 to 2 is given here. P V square equal to constant. So what does that means? So that means from 1 to 2, the relation between P and V is given by this equation. Wherever, anywhere you take, starting from 1 till the end of state, till the end of the process state 2. So it is, this equation is valid. That means I can write it, if I substitute this at ends, initial and final condition, I can substitute in this equation. Okay. Then what will happen? P1 V1 is equal to some constant. Similarly, at the end state, P2 V2 will also be equal to same constant. So therefore, I can write equation like this: P1 V1 is equal to P2 V2. P1 V1 square is equal to P2 V2 square. Right? Is it clear? Is this clear? Are you
Yes,
able to
sir.
follow what I'm saying? Okay. So now, if you see in this equation, pressure 1 is known, volume at state 1 is known, volume at state 2 is known. But pressure at a end state 2 is not known. Can you determine the pressure at a state 2? Can you calculate the pressure at a state 2 using this equation? Can we calculate? Because here,
Yes, sir.
yeah, all of you please calculate. Do that. Do it and tell me the answer. Yes, what is pressure P2?
80.
Hmm?
80 pascals.
80 pascals.
80 into 10 to the power of 5 pascals.
80 to 10 to the power 4. Okay.
5.
80 into 10 to the power 5. No, how it is possible? It has to be less, no? Pressure at P1 and pressure at P2. P2 should be less than P1. 80 into
500
0.5?
00 into 10 to the power 5.
0.5. Huh? Please do that calculation properly. Algebra, very important. Properly you have to do calculation. Don't be in hurry. Calculation is skill, not knowledge. You have to practice. Simply reading will not help you. You have to practice every day. Only then you will be able to operate calculator properly.
10 into 10 to the power of 5 pascals.
10 into
5 pascals.
10. I doubt.
5 into 10 to the
Check madam properly. See, P2 is equal to P1 into V1 by V2. Right? V1 by V2 whole square. What is V1 by V2? V2 by V1 is 2. So V1 by V2 will be 1 by 2. 1 by 2 whole square. 1 by 2 whole square will be 1 by 4. Correct? 1 by 4 into 20. How much it will be?
5.
Huh?
5 into 10 to the power 5.
5 into 10 to the power?
5 pascals.
5. Everybody getting same answer?
5 into 10 to the
Yes, sir. Yes, sir.
5.
Okay. Are you calculating or simply giving a thing? Yes. Huh? All of you have calculator with you?
Yes,
You're
sir.
using calculator, right?
Yes, sir.
Don't use your mobile. Calculate in mobile. Use the actual calculator, engineering calculator. Okay.
Okay.
Okay. So I will come to know what is the pressure at a state 2. Okay. Same thing is given here. 5 into 10 to the power 5. Same calculation I have shown here. Okay. So now I know this process. I know pressure and volume at state 1. I know pressure and volume at state 2. I know pressure and volume at state 2. State 3. Right. and I know what are the processes. From 1 to 2, it is P V square is equal to constant, relation between pressure and volume. From 2 to 3, it is constant pressure. Pressure is constant. From 3 to 1, it is volume constant. So I know all the processes. I know the relation between pressure and volume. It's very simple now to calculate the work done. So what is work done in process 1, 2, 3, 1? Right? It starts from 1, 2, 3, comes back to 1. So work done in process, work done in cycle 1, 2, 3, 1. Right? Why? Because it starts with 1, goes to 2, then 3, then comes back to 1. Therefore, it is written like this. Okay. So if I want to find the work done here, how to find out? If I know if there is one equation to define relation, suppose there is a process. Process is such that relation between pressure and volume is explained by only one relation. Then you can simply do the integration and finish it. But here it is not. Here the relation is different, right? It is polytropic equation. Here it is straight line. Here again one straight line. So equations are different for segments. This is one segment. This is another segment. This is another segment. So when the equations are different in segments, you have to use a different integration. Okay, you have to split total integration into parts. Okay. So work done in cycle is equal to work done in process 1 to 2 plus work done in process 2 to 3 plus work done in process 3 to 1. Okay. So now please find out work done 1 to 2. 1 to 2, what you have to write? Integration PdV from 1 to 2. Right? So there is a relation between P and V. Substitute that. Similarly here, integration W is 2 to 3 is equal to integration PdV over 2 to 3. You know the relation between pressure and volume here. Please substitute that. Similarly, W to 3 to 1, work done between process 3 and 1 will be integration PdV over 3 to 1. Here also you know the relation between P and V. Please do substitute and find the value. Are you able to carry out? Are you doing it? Yes. Are you able to do it or not? Are you doing it? How much time it takes? Don't keep quiet. Do the calculation. Prashant? Find out separately W1 to 2, 2 to 3 and 3 to 1. Can anybody tell me what is work done in process 3 to 1? What is work done in process 3 to 1?
1 into 10 to the power of 5.
3 to 1, process 3 to 1, what kind of process it is? What is the nature of process 3 to 1? How do you define? 1 to 2 is polytropic process. 2 to 3 is constant pressure process. What is 3 to 1?
Constant.
Constant volume. So constant volume process, what is work done? What is the work done in a constant volume process?
0.
0, right? Obviously. No work is done.
Yes.
Constant pressure process, what is work done?
1.
What 1? Pressure into
Volume.
change in volume, correct?
Volume. Yes.
So volume change in volume is how much? 2 minus 1,
0.
1. Pressure is
0.
what is the pressure? Pressure is 5.
5.
So 5 into 1, correct? Then what is work done in a process 1 to 2? You are able to do it or not? If you don't understand, please ask me. Don't keep quiet, okay?
5 into 10 to the power 4.
What? Which one it is?
1 to 2. Work done from 1 to 2.
Sorry?
Work done from 1 to 2.
Yes? Did you calculate all 3 work done? 3 to 1 is 0. 2 to 3 is 5 kilojoules. 1 to 2 is how much? Are you able to do it or not? If you're not able, tell me.
1
1
kilojoule.
Oh man.
5.
Integration PdV, correct. So there you have to substitute for a P, okay, in terms of V. So if you differentiate the equation, what you will get there? PV square equal to constant. That you can write it as P equal to or V equal to V square is equal to 1 by P. Sorry, P is equal to 1 by V square. If you differentiate that equation, no, don't differentiate. P is equal to 1 by V square. Substitute that in place of P. So then you integrate. So d dv divided by v square. Integration of a dv divided by v square. So that integration will be how much? Dx by x square. How do you integrate?
V to the power minus 3 by minus 3.
V to the power
Minus 3 by minus 3.
hey,
Minus 2 by
integration ಹೇಗೋ ಮಾಡ್ತೀಯಾ? Minus 2 plus 1. Correct.
okay. Minus 1 by
minus 1 by
minus 1.
minus 1. Correct. V to the power minus 1 divided by minus 1. So then you substitute, that will be nothing but 1 by minus 1 by V integration. Substitute upper limit and lower limit. Upper limit is V2, lower limit is V1. So then what you get, minus 1 by V2, minus of minus will become plus 1 by V1. So that means it is 1 by V1 minus 1 by V2. So there it is, constant is C. What is C? C is equal to either P1 V1 or P2 V2. Either way you can write it, because we know that the PV to the power PV square is equal to constant. So that means P1 V1 square is equal to P2 V2 square is equal to constant. So you can substitute either one, P1 in terms of P1 V1, or you can substitute in terms of P2 V2. So substitute that and simplify. What do you get? I told you to do this homework, derivation. All of you have done it or not done? You know how to find out work done in a polytropic process? Prerna? Prashant? Alvin? Satmani? Yes? Please answer. You don't keep quiet. It should not take so much time. You have any difficulty, you tell me. Prashant, are you able to do this? Prerna? Alvin is there? Ashit is there.
Yes, sir. Yes,
Yes,
sir.
what else? Are you calculating it? Are they able to calculate or not, man?
Yes, sir.
Did you find the work done for polytropic process? These three, you have to do integration. Integration PdV 1 to 2, 2 to 3, 3 to 1. This I said 0. This one is easy. P into V2 minus V, P into V3 minus V2. Okay. This will be V3 minus V2. This one is are they able to do it or not? So if you solve this equation, you will get finally this value. P2 V2 minus P1 V1 divided by 1 minus n, or if you take minus common, it will become P1 V1 minus P2 V2 divided by n minus 1. Okay, like that you have to solve. That index is n. N is a, that is a P for polytropic process. In this equation, it is n is equal to 2. Right? If you substitute that, you will get the answer. Is this clear? If you have to remember this equation for polytropic process, work done is given by this equation. Please remember this. Don't forget this. Okay? Are you able to follow what I am saying here?
Yes, sir.
Okay. Substitute and find out answer. So here P2 I know it is 5 into 10 to the power minus 5 into V2 is 0.1. P1 is 20 into 10 to the power 5. V1 is 0.05. N is equal to 2 because V square it is given. Therefore, N is equal to 2. 1 minus N. This one is pressure into volume and this volume. So if you hello sir. I heard it. I heard it. Seventh BL. Third and seventh BL. ಹೌದು ಕರೆಕ್ಟ್. ಹಾಂ ಹೌದಾ ಹಾಂ ಕಳಿಸಿ ಕಳಿಸಿ ಸರಿ ಸರ್ ನಾ ಕಳಿಸಿ ಕಳಿಸಿ. Yes. Did you calculate how much it is? Prashant? Are you
Not
there?
over, sir.
Huh?
Not over.
Not, okay.
Not over. Not over.
Okay, good. Yes, did you complete this? How much it takes? Simple algebra it is.
0.25
Huh?
10 to the 5 kilojoules, sir. Answer is 0.25
0.25 into 10 to
10
the
to the
power,
5 kilojoules. 5 kilojoule.
not kilojoules, 5 joules it is. Okay,
Okay.
it will be, or you can write it as 25 kilojoules.
Kilojoule.
Okay.
Okay, sir.
Oh, sorry, there's a mistake here. It should be kilojoules. There's a typing mistake. It's a kilojoules. Either kilojoules or into 10 to the power 3 joules. Okay. Clear? Everybody is able to get this answer?
Yes, sir.
Okay, this equation, don't forget this. For any polytropic process, this is the equation. Okay. This is a power of a V. Okay. N is nothing but a, what is the power of a V in that equation? P V to the power N, right? Equal to constant. So this is a direct answer. If you can derive this, it's okay. If you can remember, it's still better. Clear? Okay. So try to solve this problem. A gas expands quasi-statically in a piston cylinder arrangement against atmosphere and a spring. Okay. So piston is other end. One inside there is a gas, other side it is atmospheric pressure, and there is a spring loaded. Right. Piston is spring loaded. Initial pressure and volume are. Initial pressure is 400 kilopascal and 0.2 meter cube is the volume respectively. Final volume and the final volume of gas is 0.6 meter cube. Determine work done by the gas if the spring force is proportional to volume of a gas. Assume atmospheric pressure as 101.325 kilopascal. Okay. Is it clear? Problem? Can you solve this? Read the problem carefully and try to solve this. Such problems you can expect in question paper exam.
Sir, how many more question appears for
10
problems?
marks. 10 marks. This question is for 10 marks. Sometimes 6 marks will be there. If it is simple question for 5, this is 10 marks. Previous problem also 10 marks. So to solve this problem, what is given here? Let us look at what is given. There is a gas inside the cylinder, right? And there is a moving piston. So this gas has a pressure. Outside there is atmospheric air. Here atmospheric air will be there. It has got some pressure. Atmospheric air pressure is 101.325 kilopascal. Okay. Inside pressure is 400 kilopascal. Right. Then there is a spring. Right. So when this piston moves, this spring will resist its movement because there is it will try to repel. Spring based on spring constant. The force exerted by the spring will be, if the spring constant is K, what will be the force exerted by the spring on the piston? If you compress the spring by X amount, what will be the force exerted by the spring? You know or you don't know? You know spring constant? Yes or no? Please respond, don't keep quiet. Are you listening to me? Alvin?
Yes, sir.
If you compress spring, let us say there is a spring, free spring, right? If you extend it, stretch it, or you compress it, small amount, X amount, then what is the force exerted by the spring? You know this or you don't know? How to calculate the force? Come on,
MA,
quickly.
M into A. MA. M into A. Mass into
Mass. There is a mass, man. It is a displacement of the spring, I am saying. Spring length reduces by amount X, or its length increases by amount. The other end it is fixed. The spring, the other end is fixed here. Okay. So it is spring loaded. This is called spring loaded. If you compress the spring or extend the spring, what is the force exerted by the spring?
K is equal to minus F by X.
K is equal to minus F by X, or F is equal to K into X, right?
Yes, sir.
Huh? So the force F will be opposite to the displacement X. Correct? If X is the
Yes, sir.
displacement, then force will be opposite to that. Therefore, that minus sign comes there, right? So this spring force and the force of the atmospheric air. Atmospheric air will exert a force that will be equal to area of the piston into atmospheric pressure plus spring force, right? Will be balanced by the pressure inside. Okay, so pressure inside is 400 kilopascal. Okay, so this here the force exerted by this the spring is proportional to the displacement of the piston. Suppose piston moves by small amount x, that force will be proportional to that x. If x increases, force increases. Okay, so like that it will happen. So during the quasi-static process, this boundary is moving against a force, right? So when you move this boundary against a force, work is done by the system. So how much is that work done? That we have to calculate. So for that, what I need to do, I need to find out the relation between pressure and volume change. Or if I know the pressure, this force change, that thereby also I can calculate. So let's see what are the values given first. What is given? V1, initial volume is given. It is how much? How much is initial volume? 0.2 meter cube. Then final volume at state 2 volume is 0.6 meter cube. Okay. Then what else is given? Initial pressure is 400 kilopascal. Okay. Then let us look at what happens during the process. During the process, what is happening at the boundary? There is a balance between inside and outside. There is a force equilibrium, right? The process is equilibrium or a quasi-equilibrium process. Is that known as what we call them as quasi-equilibrium? Equilibrium means no change. This is change, but a very slow, right? During change, there is a balance is there. Both side forces are balanced. Okay? That is, these are known as quasi-static processes or quasi-equilibrium processes. So here, this pressure exerted by the force exerted by the inside gas is balanced by the outside force, right? This piston moves small amount. This outside pressure increases. So this also gets equalized. Like that, during the journey, pressure force is balanced on both sides. Okay, that is the nature of the quasi-static or the quasi-equilibrium processes. So there is a pressure force exerted by so this pressure is balanced by the outside pressure. Instead of force, I am saying pressure. So there is this pressure is causing the boundary to move outwards. Okay, when it is moving, it is balanced by the outside pressure. Okay, so what is outside pressure? Outside pressure is equal to this pressure is equal to outside pressure. What is outside pressure? Outside pressure consists of atmospheric pressure plus spring pressure. The pressure equivalent of a spring force. Spring will also exert some pressure on the gas. So these two I have to find out. I know this. Okay, I need to find out this. Okay, how to find out that? So if you take this equation, P is equal to P atmospheric plus P spring. Okay. So I know that spring force pressure will be the force divided by area. Area of the piston is constant; it is not changing. So you said spring force is proportional to the displacement. So displacement is the piston displacement here. Therefore, it is displacement. It is proportional to the displacement. Okay. Or in other words, you can write it. I can write this. The spring force is proportional to the volume. Why I write like this? Can you guess?
Constant. K is the constant.
How did you get this equation? Do you agree with me or not? This
Extra
spring pressure exerted by the spring is equal to, okay, what it is? Force exerted by the spring divided by area of the piston. Correct? Are you following me? So if you take here, area is constant, this pressure force is equal to displacement of the piston into spring constant. I call the sum constant, it is K. So therefore it is basically X. X displacement of piston is proportional to volume. We know that volume. So therefore you can write spring force is proportional to volume. Okay? You can write in terms of a volume. Are you getting this? All other values are constant. Only variable is X. Volume also depend. Volume is directly proportional to X. Pressure is also directly proportional to X. Therefore, I can write spring pressure is equal to K into some constant into volume. Are you following me?
Sir, could you explain it from P is equal to P ATM plus P spring?
This you did not understand.
No.
This one. Balance here.
Yes,
P is
sir.
equal. Okay.
Yes, sir.
So this is a piston boundary, right? This piston is moving. How it is moving? This movement is caused by the gas pressure inside. This pressure is moving this boundary. So when this piston is moving, it is always in equilibrium with outside force, outside pressure. Okay. So only then you can do this calculation. If it is not an equilibrium process, then you cannot apply. This PDV equation is valid only for an equilibrium process. If the process is not equilibrium, then you cannot use a integration PDV. So here we are assuming it is quasi-statically. See first statement. Gas expands quasi-statically. What is the meaning of that? When the boundary is moving, inside force and outside forces are balanced. That's the meaning. Is that clear to you how this balance comes from?
Yes, sir.
Okay. So inside, what is the pressure force? Inside pressure, I know P. When boundary is moving, this boundary is not stationary. It goes on moving. At every instant, when this boundary is moving, inside pressure is equal to outside pressure. What is outside pressure? Outside pressure is consists of a constant pressure, atmospheric pressure, which does not change. It is constant. Plus spring pressure. What is the spring pressure? The spring, when it gets compressed, it exerts a force. That force gets distributed over the piston, right? So this force varies. It proportionately increases with the displacement, right? When piston is moved out, spring is compressed. The compression of the spring goes on increasing. Therefore, proportionately the pressure exerted by the spring force goes on increasing. So therefore, the spring force is proportional to the volume. Volume and spring force are proportional. Therefore, you get this equation. P spring is proportional to V. Then proportionality constant I convert into equal. When I do that, it will become some constant I have to multiply. Some constant I call it as K. Is that clear to you?
Yes, sir.
Okay. So PE atmospheric is constant. P spring force is variable, and it's a relation I came to know from here. P spring is equal to K into volume inside the cylinder, right? So once I know this equation, I will apply initial and final conditions and find out K. Very simple for me, right? Can I do that? Yes or no? So if you take this, if you have initial condition, if you apply in this, what is initial condition? Initial pressure is 400. So substitute in this equation. 400 plus 1 atmospheric is 101.325 plus P spring is K into V. So in this equation, all values are known except the K. Initial volume is also given, right? So substitute that and find out K. Can you find out K value? Do that. So I have substituted here. Initial condition 400 plus 101.325 spring force. I will substitute this also. If I substitute, what happens? This comes this side. So spring force is equal to K into V1 into is equal to 298.67. Right? Find out the K. V1 you know. What is K then? How much is K? Simple calculation it is. Quickly do it. V1 you know, right? You have noted down V1 or not? Have you noted down V1 value? If you don't, then I have to bring the previous slide. What is V1 value? V1 is 0.2. Substitute that.
$149.33.
Okay, fine. Right? 1493.75 into 10 to the power 3. Are you getting same answer? Something different? I don't know. Because this is kilopascals, no? You have to substitute into 10 to the power 3. Right? Everybody getting same answer? All of you calculated? Prerna, did you calculate this?
Yes, sir.
Okay. So next is, I know the spring pressure in terms of a relation between pressure and the volume. Right? Next job is very simple. Just find out work done. What is work done? Work done is done in the process 1 to 2. So 1 to 2 I have plotted in PV diagram. If I know the equation between P and V, it's very simple process. Do the integration. That's all. W1 to 2 is equal to integration P dV over from V1 to V2. Substitute in this P in terms of P. Do the integration. That's all. Do that. You have relation for P, right? What is P is equal to? Pressure P is equal to atmospheric pressure plus K into V. Right? In place of P, you write it as atmospheric pressure P atmosphere plus K constant into V volume. Do the integration. Yes. Are you able to do the integration?
Sir, what we should substitute for P here?
P is equal to previous slide you have shown, no? What is P is equal to?
P atmosphere plus KV1.
P is equal to P atmosphere plus P spring, right? What is P spring? P atmospheric is constant, 101. P spring is KV. K value I have found out here. K value I know here, right? Substitute this K value there, right? P in place of P, write P atmospheric plus K into V. K is constant into dV. Do that integration. Prashant, Alvin, Satmani, are you doing calculation? There is a mistake here. It is actually 3. Somebody said no 1493.375. Okay, I have done a mistake here. While substituting, I have done mistake. Okay, please take care of it. Somebody says 933 is correct. You are right. Yes, Prashant, Alvin, Tatmani, Ashit, and there is Puneet. Yes, you are able to do the calculation. Quickly finish it, man. Simple problem it is. How much time you are taking? You should get used to doing the operating calculator. It takes so much time, then things will not work. Yes. Yes, please respond. Yes, please. Are you with me? No response. Are you listening to me or not? Anyone, please? Prerna? Yes. This is how you have to integrate. P atmospheric plus P string. P string will become K into V. If I do this integration, this is constant, K is constant. So therefore my equation will become P atmospheric into V, right? dV. Integration of dV is V. Integration of V dV is V square by 2, right? This is what I write here. Then I substitute upper and lower limits. If I substitute upper and lower limits, it will be like this. Then you substitute the values and find out the work done in the process 1 to 2. So do it as assignment, homework, and tell me tomorrow. Okay, we'll close this session now. Hello, can you hear
Sir,
me?
answer.
Answer?
Sir,
What is
answer.
that? Yes, tell me.
279.47.
279.47. Let's see. Others have calculated? Only one person. Who is this?
Prashant.
Prashant. What about others? Prerna? They have done
Sir, I
calculation
don't know
or
it
not?
is correct or not.
Sorry, I don't. Let me see. I want to see. I don't remember the value. It's in next slide. What about others? They got same answer. Anyone of you please respond. Why others are not speaking? Any problem?
Sir, I did not substitute the values for V2
Substitute
and
value. Do that. What is that? How much time it takes?
We are
How do you
trying.
do it? All the values are known here. Atmospheric pressure, V2 is known, V1 is known. Substitute and find out. That's all. K value is known. What about others? Hello. Hello. ಹೇಳ್ಬಿಡ ಅದನ್ನ ನಂಬರ್ ಕೊಡ್ಬಿಡೋದು ಸುಮ್ಮನೆ ಹೇಳ್ತಾ ನನ್ನ ನಂಬರ್ ಕೊಡು ನನ್ನ ನಂಬರ್ ಕೊಟ್ಟು ಅವ್ರಿಗೆ ಫೋನ್ ಮಾಡಂತ ನನಗೆ ನನ್ನ ನಂಬರ್ ಕೊಟ್ಟು ಫೋನ್ ಮಾಡಂತ ಸರಿ ಆಯ್ತು Hello. Yes, everybody calculated answer? What about other? Prerna, you are not doing any calculation. Last class asked you didn't do. What are you doing? What about rest of the class? No response at all. Only Prashant is speaking. Only few people are talking. What about others? Satmani is there?
I got 239, sir.
239. Who is this?
Alvin.
Alvin. What about Prashant? How much he got? Okay, we'll go to the next slide. 279. Okay, let's see what is the correct answer. I don't remember. Let us see what is the correct. Calculations available in next slide. Let me check. I will show you. So you have substituted like this. Your substitutions are like this only, right? Okay. So you have to square this. If you have forgotten, then there will be a mistake. Okay, please check whether you have done square of this volume. You have to square. Okay. So if you do that, you get values like this. Step by step, I have shown here. then it will be like this. The final answer is 279.53. This fraction might be slightly different because here I have done a mistake. It is 1493.375. So if you have taken that value, then it will be slightly different this time. Okay. Other than that, there should not be any difference. 279 is fine. Somebody got 279, no? Somebody, who is that?
Prashant.
Prashant, you got 279, no? Your value is correct. What about others? Alvin, how much you got?
239.
239. Check. Please check. Any mistake you have done?
239.
There must.
I'll check.
Please check. Compare these values here. This you have done this volume square. Have you done this square?
Yes, sir.
Then dividing
Volume,
two. Huh?
Yes, sir. That is here it is wrong, sir.
Where it is?
Atmospheric pressure into 0.6 I didn't done.
Atmospheric pressure?
Into 0.6 is there now, sir. 101.325
Huh.
into 10
Into 10 to the power 3. Correct.
into 0.6 I forgot to do that, sir.
Okay. Do that. Huh? You'll get this answer. Okay.
Okay.
Okay. So all of you finish this. Huh? Okay. We stop here. Fine.
Okay, sir.
Okay. So we'll close the session here. I'll download attendance. Stay with me for a few more minutes. We'll finish this. And if there are any questions, please ask. Okay. Anyone has got any doubt?
Sir,
There are so many people. Why? Sorry. Yes.
Can you
Sorry. Somebody said something. Who is that? Alvin?
go the last slide, sir? Last slide.
You want to see the last slide? Okay. 1 minute. I'll show. Last slide. Screen is visible to you, right? This is visible to you. Okay.
Sir,
Yeah. Please. This is what you want, right?
last slide, sir.
This one, right? Or
Yes, sir.
previous slide?
This one. This
Okay.
one, sir.
Yeah. Write down. Okay.
Okay. Yes, sir. Thank you, sir.
Okay. Done.
Yes, sir. Done.
Okay. So there are so many people. Why people are not talking? Are you with me or out of sync? There are so many people in the meeting. Adish never speaks. Ashit Shetty is not talking at all. Are you doing calculation? Ashwin, Dikshit, Durga, Guru Kiran, Jaswant, Jeevan, Arpit Rai. What these people are doing? They are not doing any calculation since. Ishan, Karthik, Mohit, Nishit, Nitin Rai, Prajwal. What you people are doing? What is this? Prerna. Somebody has sent a message. ಹೇಳ್ಬಿಡಿ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳಿ ಜಾಸ್ತಿ ಹೇಳ್ಬಿಡು ಏನ್ ಮಾಡೋದು Hello?
Yes, sir.
Yeah. Why others are not speaking? They are doing calculation or not? That is my worry. So many people are there. They are not at all talking. Vikhyat, I'll call one by one. Yatin Kumar, are you there?
Yes, sir.
Are you doing calculation? You are not doing calculation. You are watching movie here. Simply watching the video. You have pen, paper, calculator with you. Switch on your video mode and show me your face. Who are you? Let me see your face. Switch on the video. Yatin, can you hear me? Yatin, Yashwant, Sujan is leaving. Shiv Prasad, you are not doing calculation it seems. Sumant, Satmani, Ranjit, Rakesh, Puneet Rai. Puneet Rai, can you hear me? Prashant is fine. Prajwal, Puneet, can you hear me?
Yes, sir.
Are you doing calculation or not?
Sir.
Yes, sir.
No, you are not responding at all. What is the answer you got? You have calculator, everything with you,
Yes, I'm doing, sir.
but you are not answering any question, simply keeping quiet. You have to give some answer.